solution, or person has a dissolution problem. That's what we did earlier with the coffee cup. If you have more questions, feel free to ask. Okay, vapor pressure I've already talked about too. Oh, I'm killing it right now. Let's do concentration, and then we'll kind of move on from there. See what we can do here. I came with an example actually. I think this is an old exam question. Pretty classic sort of problem. There's lots of, every one of my tests has one. Alright, here's how I do these. I kind of find out the information I have. We have ethanol, and we have water. I'll just put W for water. We have 10 mils, 100 mils. Let's see, 0.789. This is for ethanol only. And this is for the, not for water. I guess we have one more thing. The solution. 100 mils of solution. Oh, 100. Sorry. This is really 100 milliliters of the solution. I don't want that there. Okay. The solution density is 0.982 grams per liter. All right, that's what we got from the question. To make the solution, I'm adding water. So water is my solvent. So let's find out a little bit of information, and then I'll do my calculations. Okay. If I multiply the, let's change colors here. 10 milliliters times 0.789 grams per milliliter. I've got 7.89 grams of ethanol. If I do the same over here on the right, 100 milliliters times the solution density, I can find I have 98.2 grams of solution. Okay, zoom out a little bit more. So I've got now my solution my solution mass. I got my ethanol mass. Let's find water. Water would be, the mass of water would be 98.2 minus 7.89 grams. This would be my mass of water. I didn't calculate that, but that's a number. If somebody has that, I'm happy to write it down. Looks like around 90. 90.31. I'll believe that. Okay. Okay, I'll put this question back up later. All right. So that's the mass of water. I've got the mass of ethanol, the mass of solution. Now let's find all the moles. And once I have those, then I'm going to start doing my calculations. I've got 7.89 grams of the ethanol. And then I need to multiply by the molar mass to get moles. Moles of ethanol. So ethanol is given in the problem, it's C2H5OH. It's going to be about 24 plus 6, 30, 46 grams per mole, something like that. I also didn't calculate that. That's how you would find it. And then the same for water. You'd go 90.3 grams of water times 18 grams per mole. And then you'd find the moles of water. Okay, so let's notice what I have. I've got the moles and mass of water and the moles and mass of the ethanol. I have all the information I need to rush, kind of punch through and get all the things that I was asked for. Let's start first with volume percent. Volume percent is going to be what volume? Yeah, the volume of the ethanol which is what I'm interested in, 10 milliliters, divided by the solution volume, 100, times 100%. It's just going to be 10%. Okay, so there's the volume percent. That's the first thing I was asked for. The next I was asked for is the mass percent. Let's find that. Mass percent is the mass of what? The ethanol, 7.89 grams, divided by the total mass of the solution mass, 98.2, I believe it was, grams times 100%. I pre-calculated that, and that was 8.03. Okay, so there's the mass percent. Oh, I wasn't asked for, oh, I was asked the mass percent. Good. Okay, what else was asked? The mole fraction, X. The mole fraction of ethanol. Oh, yes, thank you. The mole fraction of ethanol, that's the moles of ethanol divided by the moles of ethanol plus the moles of water. I did the work for that, but I didn't calculate those numbers. But I did calculate the answer, which is what you're all excited about. That's 0.0330. What's the units? Nothing. These were percent, that's nothing. Okay, next. Molarity. Molarity. The moles of ethanol divided by what? Volume of solution, which is what? There was 100 milliliters, but I need it in liters. So 0.1 liters. I calculated that at the time. I got 1.71 mole. And the last one is molality. Oops, sorry. That's the moles of ethanol divided by what? The kilograms of the solvents, that'd be kilograms of water. That was 90.3 grams, or and I got 1.89 mole out. Okay, I'll give you a moment to process that. I'll get back to what we were covering. Let me finish the final part if there's no questions. Okay? Henry and Raoult's law. I guess for those of you who Google car haven't quite got here yet, so this is the craziest part that we're covering now. Henry's law says for what state is the solute? Gas, liquid, or solid? Gas, and then the solution or the solvent? Liquid. So it's a gas and a liquid is what Henry's law is about. It says that if you put more pressure on the gas, you can increase the concentration of the gas or the solubility of the gas in the solution. So say a soda can, the more pressure you put on the can, the more CO2 gas you can get in the soda. So they're directly proportional. This is just a constant. It's plug and chug. So you have to be given K and P. The only variant of this is if you kind of have something that sort of looks like a gas law of sorts, when we did gas laws, where it's state 1 and state 2. So you don't have to be given Henry's law constant. You can be given, say, 2 of the pressures and 1 of the concentrations. By the way, if it's in this form, what's the units of the pressure? It won't matter because it's a ratio. And also the units of the concentration won't matter as long as you're consistent, because it's in a ratio. So there's no required units for this one. For this one, how do you know the units? It's based on which one of those three? C, K, or P? K. K is, usually that's the easiest. You don't have to do it that way, but usually you're going to go by the units given in the K value. That's typically the easiest way to do the problem, unless requested otherwise in the question. Okay, Raoult. I'll just say a little bit about this, but if somebody has an example, that would be ideal. What you're typically going to do is when you have a solution with A and B in solution, so compound A and compound B are mixed together. This is just a slash. Both of them are in there. What you want to do is you'll usually be given mass. You'll want to convert that to moles of A and B. After you get the moles, that's of A and B, then you'll want to get the mole fraction of A and the mole fraction of B. The mole fraction, remember, is the moles of what you're interested in. Say this one, moles of A over total moles. All right. Once you have that, then you're usually, I guess I'll write here, given the pure pressures, PA naught and PB naught. Again, what's this the pressure of? PA naught is the pressure of what? Only A. And this is the vapor pressure of only B. So the naught means just that. It means pure, all by itself. So then you would use Raoult's law to find the partial pressure, say of A, is a mole fraction of A times the pure pressure of A. And the partial pressure or vapor pressure of B is a mole fraction of B times the pure pressure of B. So if you're new to this, this looks really similar to Dalton's law from Chem 2A. And then the final part usually is to find P total, which is equal to PA, partial pressure of A plus partial pressure of B. Usually that, for most problems, this is the flow of the problem, or kind of a typical problem. Okay? So you go, sorry, I forgot one arrow. Use this and this to kind of go to that part. All right. How was this for most of you? Helpful? Yeah. Thumbs up? Good.